confinements to probability in analyzing the records on the boys who receive treatments at a children's hospital. Probabilities related to the following events A, B, C were discovered for a boy picked at random from those who received treatment. Event A, the child has wheeze. Event B, the child has headache. Event C, the child has stomachache. It is given that events A, B, and C are mutually independent and that probability of A is equal 0.1, probability of C is equal 0.2 and probability of A union B is equal 0.37. First one, show that probability of B is equal 0.3. Second one, find the probability of complement of B given complement of A. Third one, find the probability of child having stomachache but neither the wheeze nor a headache. Last part, if it is given that the child is suffering from exactly one of the above mentioned conditions, find the probability of it being the wheeze. Answer for this question. These are the data given. A, the child has a wheeze. B, the child has a headache. C, the child has a stomachache. And also, this one also given, probability of A 0.1 and probability of C 0.2, probability of A union B 0.37. A, B, C are mutually independent. From this, we can say probability of A intersection B is equal probability of A into probability of B. And one more conclusion, probability of A intersection B intersection C is equal probability of A into probability of B into probability of C, and complement of these events also mutually independent. Therefore, probability of complement of A intersection complement of B intersection complement of C is equal probability of complement of A into probability of complement of B into probability of complement of C. The first one, we want to find out the probability of B. We already know this formula, probability of A union B is equal probability of A plus probability of B minus probability of A intersection B. This is equal probability of A plus probability of B minus, for this one we can say probability of A into probability of B. A and B are mutually independent. By substitution, probability of A union B 0.37, probability of A 0.1 plus probability of B minus probability of A 0.1 into probability of B. When simplifying this further, 0.37 minus 0.1 is equal 1 minus 0.1 into probability of B. Therefore, 0.27 is equal 0.9 into probability of B. So, probability of B is equal to 0.7 over 9. This is equal 0.3. The second one, we want to find out probability of complement of B given that probability of, we want to find out the probability of complement of B given that complement of A. Probability of complement of A is equal 1 minus probability of A. When substitution 1 minus 0.1, therefore probability of complement of A is equal 0.9. By De Morgan's law, complement of B intersection complement of A is equal complement of A union B. Therefore, probability of complement of B intersection complement of A is equal probability of complement of A union B. This is equal 1 minus probability of A union B. Substitution 1 minus, for this one we are given 0.37. Therefore, probability of complement of B intersection complement of A is equal 0.63. By conditional probability, probability of complement of A given that complement of A. How can we write that? Probability of complement of B intersection complement of A over probability of complement of A. Substitution, for this one we can substitute 0.63 here over probability of complement of A here 0.9. When simplifying this one 0.7, the second part. Third part, having stomachache and no wheeze and no headache. So, how can we write this statement in Z notation? In the Z notation, stomachache, no wheeze, no headache. Therefore, we can write like this one. See, stomachache and complement of A, that is no wheeze, and complement of B, that is no headache. So, what is the probability of C intersection complement of A intersection complement of B? Using this statement A, B, C are mutually independent, we can write like this one. Probability of C into probability of complement of A into probability of complement of B. When substitute probability of C 0.2 and probability of complement of A 0.9 already calculated, and probability of complement of B, the previous part probability of B 0.3, therefore probability of complement of B 0.7, 1 minus 0.3. When simplify this one, 0.126. So the answer, probability of a child having a stomachache but neither the wheeze nor a headache is 0.126. Now the fourth part, this one. Exactly 1. We will do some revision in our Venn diagram set notation. Universal set is a 3 set. Set A, set B and set C. A only. How can we shade this one? A only. This area. The A only, the green color shading. So in set notation, how can we write down this one? In the set notation, A only, A intersection complement of B intersection complement of C. Is the A only in set notation. A intersection complement of B intersection complement of C. And B only. Shade the region is the B only. In the set notation, B intersection complement of A intersection complement of C. C only, shade this region, this one. In the set notation, C intersection complement of A intersection complement of B. So exactly 1, the region, exactly 1 is this one or this region or this region. Exactly 1. The set notation we can write like this one. This region or this region or this region. A intersection complement of B intersection complement of C, or B intersection complement of A intersection complement of C, or this one. C intersection complement of A intersection complement of B. Let this set is X. Exactly 1. Set is X. A intersection X. In the set notation, A intersection X. Set is these 3 green region, blue region and red region. Intersection of A. Yeah, intersection A is this region. This green color region is the A intersection X. X is all 3 region. Now A intersection X is equal this green color region. A intersection complement of B intersection complement of C. Probability the child is suffering from exactly 1 disease is probability of X. Exactly 1. That is the probability of X. So probability of X, this is the set X. Therefore probability of X is equal probability of A intersection complement of B intersection complement of C. In set notation union, in probability it becomes as a plus. Probability of B intersection complement of A intersection complement of C plus probability of C intersection complement of A intersection complement of B. Since A, B, C are mutually independent, complement set also mutually independent, therefore probability of X is equal for this one probability of A into probability of B, probability of complement of B into probability of complement of C, plus for this one these three are mutually independent, probability of B into probability of complement of A into probability of complement of C, plus this one probability of C in the probability of complement of A in the probability of complement of B. When substitute, we already know probability of A 0.1, probability of complement of B 0.7, probability of complement of C 0.8. Then substitute for this one. Probability of B 0.3, probability of complement of A 0.9, probability of complement of C 0.8. For this one, probability of C 0.2, probability of complement of A 0.9, probability of complement of B 0.7. When simplify, this one 0.056. When multiply this one 0.216, when multiply this one 0.126. So this one probability of X is equal 0.398. Probability of being this given that child is suffering from exactly one of the above condition is probability of A given X. The question in the notation we can write like this one, probability of A given X. Probability of being B is given that probability of being B is, that is the A, event A, suffering from exactly 1, that is the X. By conditional probability, this one can be written as probability of A intersection X over probability of X. This one, probability of, we already proved it, probable A intersection X. Here, A intersection X is equal A intersection complement of B into complement of A intersection complement of B intersection complement of C. This is the A intersection X. This A intersection X, we can write A intersection complement of B intersection complement of C. A, B, C are mutually independent, therefore complement of B and complement of C also mutually independent. Therefore this one probability of A into probability of complement of B into probability of complement of C over probability of X. When substitute probability of A 0.1, probability of complement of B 0.7, probability of complement of C 0.8 over probability of X. Here we calculated 0.398. When simplifying this one, 56 over 398. Therefore, this one 28 over 199, the last part. answer for this last part. Probability of this one B is given that exactly 1.